Like I said, this is the last section of this chapter, chapter 7-6. So we're going to learn three different things. Circles. You're like, Mr. Hamrick, we've already talked about circles this year. I know all about circles. Well, you don't, because actually, if we had time to do the next chapter, chapter 8, that's a whole entire chapter just about circles. A whole entire chapter on it, okay? We've just barely scratched the surface when we talk about circles. We're going to do a little bit of circles. We're going to do a thing called sectors, which we haven't talked about at all. You probably never even heard that before. You've probably seen this word segment. We've talked about segment almost from day one. When we did the geometry, we talked about what a segment was. But this is a little different. This is a segment of a circle. Okay, so we're going to talk about what all three of these mean. And then, what was this whole chapter about? Do you remember what this whole chapter was about? We haven't done a whole lot of it. Well, no, we have. At the beginning of the chapter, we did a ton of it. And then we took a couple lessons off. Now we're back to it again. Do you remember what this chapter was about? But the area, right? It's the area. Okay, and this time we're going to do the area of a circle, the area of a sector, and the area of a segment. All three of these have to deal with circles. Okay, a sector is a part of a circle, and a segment is also part of a circle. So let's start with the main one first. Okay, the first one that we're going to do is the area of a circle. And you may know off the top of your head right now, does anybody actually remember what the formula for the area of a circle is? Do you remember what the circumference? We talked about that in here. Do you remember what the circumference of a circle is? Pi. Just pi? That's it? Okay. Pi is part of it, and 3.14 is pi. That's true. But there's more to circumference. Do you remember? What does it mean to find the circumference? If I said, find the circumference of the circle, what are you doing? You're going the outside, the distance around that whole entire circle, okay? That's circumference. Let's write that down. We're not really going to use that today, but I'm just going to write it down because it's got pi in it, and the next thing we are going to do has pi in it. So circumference is what? 2 pi r, okay? Circumference is 2 pi r. So if I know what the radius is, where is the radius on this? Well, anywhere from the center to any point on the circle. All right, start here. That's the radius. How do I find the distance around that whole entire circle? All I got to do is know the radius. If I know the radius, I can find the distance around it. I go 2 times 3.14 times whatever the radius is. Plug all that into a calculator, and boom, I got the distance around the circle. But that's not what we're doing today. Okay, we're not doing the circumference of the circle. What are we doing today? We said it earlier in my little intro. The area, right. We're doing the area of a circle. I'm not going to go into this as much as I did with the last class, but I will talk about this. All right. Now, that's not a circle. What is that? It's a rectangle. All right. So, do you remember we did this when we talked about the area of a rectangle? We broke it down into a bunch of what? No, not rectangles. Actually, let me make this, I don't know. They do look like rectangles. Would this look better? Yeah, let's do it like this. Yeah, I'm trying to make squares out of this, all right? Just trying to eyeball it. So maybe if I put a line, that's starting to look like, it's not exactly squares, but just pretend they are, okay? Use your imagination. So when I find the area of something, anything, what am I trying to do? I'm trying to find out how many squares fit into that particular object, okay? So I got a rectangle. Again, this is not drawn very accurately whatsoever, but pretend they're all squares, all right? So how would I find the area of this? No, of this. There's no radius of this. Okay, length times width, base times height, okay, however you want to look at it. So really, you're just finding out how many squares you got in here, aren't you? Again, pretend they're squares. That definitely does not look like a square or that, but pretend they are. So 1, 2, 3, 4, 5, 6, 7, 8, 8 across, and then 1, 2, 3, 4 down like this. So what's the area of that thing? It's what? It's 32, what? We'll call it centimeters. Centimeters what? Squared, okay? What if we tried to do that with a circle, though? as bad as I made these not squares, this would be even tougher, wouldn't it? Look, what if I drew this like this, and then I split that like that, and I split this one like that, and then I come across like this, and then like this, and then like this, I don't know, then like this. Again, pretend they're squares. They kind of look like rectangles, but just pretend they're squares, okay? If I would have drawn it correctly. How many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8. But I got all this stuff over here. But look at that. Is that a square? Is that a square? Is that a square? No. Look, this kind of curves, doesn't it? You see that? See, look, if I made this a square, I still, oops, let's make it like this. Look, there's a square, but I got that little curve right there. I can make these squares smaller and smaller and smaller, and you could count up all the squares, but you still got that little curve right there, all right? Which indicates there's not going to be a perfect number of squares. Like this one right here, there's a perfect number, 32. Exactly 32, not a little bit more, not a little less, exactly 32. If I did that with a circle, I'm not going to get exactly a certain number of squares, because if I broke that into a square, I'm still going to get that little curved part right there, all right? So I can make those squares as small as I want. I'm still going to get a little bit of curve, which is not a straight line. They're not all going to be squares, okay? But if I was to take this and maybe add it to this, and if I wanted to find out exactly how many squares, you're going to have some kind of decimal to it, okay? So we have a formula for this. All that to say this. I just want you to understand what we're trying to do when we're trying to find the area of something. The area is how many squares can you fit into it. So area, and it's a circle. Remember on the circumference we used pi. Pi was 3.14. We're going to use pi again. So I'm going to put it up front this time. And then we're going to use radius, just like we did with the circumference. But watch what we're going to do. We're going to take that radius, and then we are going to square it. That's the formula for the area of a circle. So it's pi, which is 3.14. Then you take the radius and you square the radius. Everybody with me? All right, so let's draw a circle again. We'll just do a quick little example. Make it super easy. Well, let's do this. Let's put a center right here. Oops, there we go. All right, put a center right there, and we'll put a radius. We'll just put the radius from there to there. Give me a good radius for this, nothing big and crazy. 5, okay? So we'll make the radius 5. And if I ask you to find the area of this, what are you finding? You're finding out how many squares, let's say it's in inches, okay? How many 1 inch by 1 inch squares can you fit inside that circle? If the radius is 5. That's what you're trying to find when you're finding the area of something, okay? So let's put it in our formula and let's figure out what we get. So area is what? Pi, which is 3.14. Is it exactly 3.14? No. So I am not going to put an equals. Since I'm putting 3.14, I'm going to put a little squiggle equals. What's a squiggle equals? That means it's not exactly... It's what? I've used this word quite a bit. Approximately. It's approximately, okay? Now, I can put the equals here because this is an exact value of pi. As soon as I put 3.14, it changes it into an approximate answer. So it's not exactly, it's approximately. All right, enough of that. Times the radius squared. What's the radius? It's 5. That's in inches. And what are we doing to that? We are squaring it. Now, what do I do with all this mess? I just throw it into a calculator. Oh, you know what I should have done? Watch. Let's do it like this, though. Instead of putting 3.14, I could do this. Sometimes different books, different authors would rather you leave it in terms of pi. Some books would rather you put it as a decimal. Some books do both. We'll say, give me an exact answer, give me an approximate answer. All right? So an exact answer would be pi times radius 5 squared. So this is pi times what? What's 5 squared? It's 25. But if I'm going to leave it as a pi, I want that 25 to go out in front, so that would be 25 pi. That would be an acceptable answer. That's actually an exact answer. That's why I kept all those equal signs. They're not squiggly. It's exactly equal to 25 times pi. But sometimes that doesn't make sense, all right? If I was a carpenter or something like that, something working with this stuff, if I was a landscaper and I wanted to do a big old circle, a circle pool or a pond or something like that, I'm not going to use pi. I'm actually going to put in 3.14, all right? So let's put that into a calculator. I don't have it written down right now, so let's use a calculator. So it's 3.14 times 5 squared. What's 5 squared? 25, and that equals 78.5. So that it comes out to exactly 78.5, but, oops. Let's do this. But I'm still going approximate because that 3.14 is approximate. So what did I say? 78.5. All right. And it's in, what did I say it was in? Inches. So this would be what? Inches squared. So that's how you do the area. You could keep it like this. I'd give you credit. You could put it like this. I could give you credit. But you got to make sure that you look to see what the book says. Sometimes they don't say anything as far as how to write your answer. They might just say, find the area of the circle. You could write that answer perfectly fine. You could write that answer perfectly fine. Sometimes, though, I'll get to you a second. Sometimes, though, they ask you, give me an exact answer. So what would the exact answer be? 25 pi. What if they say, round your answer to the nearest tenth? Then this would be your answer. Okay? You with me? Just all depends. I don't have the book out in front of me. I don't really know how they ask you to write the answer, but be ready to do both ways. Question. They will. Well, there's no way to find the area if they don't give you the radius. Okay? They'll give you, let me say it this way. They're going to give you enough information in order to find the radius. But most of the time, they're going to give you the radius. Sometimes they give you the diameter. I didn't talk about this in the other class, and I should have. Watch. Sometimes they're going to give you this. They're going to say that this whole thing is 10. Are we putting a 10 in here and squaring it? No. What are we doing? Finding the radius, right? So they don't give you the radius. You got to figure out what the radius is. Make sense? So if they give you the diameter is 10, you're going to use the radius, which would be 5. Good question. Everybody with me? All right. Yeah, that's pretty easy. Let's talk about the second thing on our little list. What was our second thing? A sector. That was our second thing. All right, so let's talk about what a sector is. Again, it's part of a circle. So let's talk about it. Let me put a center right here. What I'm going to do is I'm going to make an angle. I'm going to take that angle from here to here. But look where the vertex of that angle is. The vertex of the angle is at the center of that circle. Everybody see it? Guys, you got to snap out of it. Some of you guys are dozing off. All right, you got to keep your eyes open. Take some notes. Write stuff down, okay? It's hard to fall asleep. It's not impossible. I've done it many times. It's not impossible to fall asleep if you're writing, but it's harder to fall asleep if you're writing. So let's write. Write this stuff down. Draw this circle. Draw this angle right here. Do you see this angle right here? That has a special name. Okay, we call that angle the central angle. All right? It's called the central angle because the vertex is where? At the center. Okay, central angle. Vertex is at the center. Now I'm going to throw something in here that's really crazy. Okay, you've never seen this before, I don't think. But I'm going to talk about it because you're going to see this later on. You got to learn it at some point. I'm going to name this angle something crazy looking. It kind of looks like a 0, almost like an O from the Orioles, doesn't it? Where that You ever see the Orioles O? It's got like a little swoosh through it like that. But this is a Greek letter of the alphabet. All right? The Greeks have their own alphabet. They got their own letters. Okay, they don't use our letters. They use their own letters, Greek letters. And sometimes in math, a lot of times in math, we borrow some of the Greek letters to represent certain things. And this is probably the first one that you ever learned, the Greek letter. The further and further you go with math, the more and more Greek letters that you learn. All right? By the time, if you become a math major in college, by the time you finish being a math major in college, you probably know about at least half of the Greek letters of the alphabet. All right, if not more. But this is our first one. And it's again, it kind of looks like an O with a little swoosh through it. Sometimes in the books, sometimes they may look like this. Maybe they put like a little bar here or here. But usually when I draw it like this. Okay, most people would hand draw it the way I do. Or I do it like they do. Okay, the Greek letter is called theta. 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 It looks like theta or theta, but we don't say it that way. We say theta, like it's an A in the middle. All right, but it's an E. It's a Greek letter of the alphabet, theta. Don't let that scare you off. It basically just means an unknown angle. So a lot of times in math, if you're trying to find an unknown angle, instead of calling it angle A or angle B or angle X or angle Y, a lot of times in math, they call that unknown angle theta. And we use that theta representation a lot. Again, it's just a Greek letter of the alphabet. Everybody okay with that? It's not that big of a deal. I mean, again, I could have called this angle A, couldn't I? All right? It wouldn't really mean anything different. It's just an unknown angle. But again, I just want you to kind of get used to seeing theta because later on, you're going to see that. And you're like, oh, okay, yeah, Mr. Hammer told me about that. It's just a Greek letter, no big deal. All right, that's what we got. So watch what I'm going to do here. I am going to shade in this chunk of this circle, okay? So it's kind of like a piece of the pie. Think of it as pizza pie, apple pie, lemon pie, whatever pie you like. If it's circular, not every pizza is circular, but all right. See what I did right there? I'm just trying to shade that in. That's what all that red stuff is. I'm shading in that part right there. You okay with that? All right. So what if theta was equal to, I don't know, that looks like a little more than 90, doesn't it? So let's call it 100 just to make it easy. So what if I wanted to find the area of, let's do this. Let's just say it's 3. The radius is 3, okay? Just making these numbers up. What if I want to find just the area of the red stuff? Not the area of the whole circle, okay? Just the part that's in red. How would I do that? This angle times the radius? Well, what's the area of a whole entire circle? What if I shaded in that whole entire circle? It would be what? Pi r squared. Agreed? This is not the whole circle. It's a chunk. It's a part of the circle. It's a piece of the whole entire circle. You with me? How much of the whole entire circle is that chunk right there? It's not a third. It's 100 degrees out of 360. You got it. It's 100 degrees out of the whole circle. How many degrees is the whole circle? 360. So this would be what? 100 what? Out of divided by 360. Everybody see that? So that's how you find the area of a what? What do we call this thing right here? No. What do we call that chunk of the pie? It was a sector. Okay? So that chunk right there, shaded in red, is called a sector. How do you find the area of a sector? You take that central angle, whatever the central angle is, I made it 100, okay? And you divide it by 360, and then you just go pi r squared. So this is the fraction of the circle that 100 degrees is. 100 out of 360. And then you just put pi r squared because that's the area of a circle. So you put that into a calculator. Okay, let's do it. Yeah, let's just put 100. Let's just put it in the calculator. So it's 100 over 360 times pi, which is what? 3.14. It's not exactly that, is it? Okay, it's approximately that. Because 3.14159, blah, 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 it keeps on going forever and ever. All right, but we're just going to round it to 2. Times the radius squared. What's the radius? 3. And then what do you do with that radius? You square the radius. So this is the work. You know how I always say show work? This is the work. There's no way in the world you can do that in your head. You're like, well, Mr. Hammer, I put it in a calculator. I think that's it's too complicated to put into a calculator without showing the work. All right? I mean, you can, but let's do it. Let's put approximately because of that 3.14. And now what I'm going to do is put that all into the calculator. So how am I going to do that? Well, I'm going to put 100 over 360 first. 100 divided by 360 equals, comes out to some crazy fraction, 2.777. It keeps on repeating. All right? And I'm just going to go times 3.14. Then I got some other number, 0.87222. And then times what? 3 squared. But do 3 squared in your head. What's 3 squared? Times 9. You hit times 9. And you get 7.85. 7.85. What does that mean? That means you could fit 7.85 squares inside of that shaded in part, that red shaded in part. I didn't give you any, what do you want to call it? Kilometers, okay. So it's a big old circle, all right? Huge circle. So the area would be what? Kilometers squared. And that's all there is to it. It's actually pretty easy. It's just one little step beyond finding the area of the whole circle, right? You're taking whatever that angle is over 360. What if this angle was 60 degrees? What would you do? What would you do if this angle right here was 60 degrees and not 100? You go 60 divided by 360. You got it, okay? What if it was 30 degrees? What would you do? 30 divided by 360, okay? You with me? What if it was, I just thought of this. I didn't do this for the other class, but what if it was 180 degrees? I want you to see this. Watch. That's right. Because so what is 180 degrees out of the whole circle? It's half, isn't it? Everybody see that? So 180 out of 360 is exactly 1/2. Half of the whole circle. What's the whole circle? Pi r squared. Well, you got to put the radius in, whatever the radius is. You got to put it in, and then you got to put 3.14 for the pi. But I just want you to see that. Does that make sense? That 180 out of 360 is half. That's half of that whole circle right there. Agreed? Yeah. All right. It doesn't always come out that pretty, like a half, a quarter, an eighth. This came out kind of weird. All right. But that's how you do it. You just take how many degrees, whatever your central angle is, out of 360, and then pi r squared. Everybody okay with that? All right, let's do the third one. The third one is where you really got to think. All right, if you haven't been awake yet, well, you kind of sunk. Tell you the truth. But you can still catch up. So now we're going to talk about the segment. All right. Now, you probably already remember talking about segments, but not the segment of a circle. You probably remember doing this. All right, here's a segment. Put a little endpoint right here, a little endpoint right there. This is AB. So this is what? Segment AB. Do you remember doing that? Yeah. This has got a little bit to do with what we're going to do today, but we're going to talk about the segment of a circle. So let's draw another circle. Let's put the center right there. What I'm going to do is I'm actually going to draw another central angle. You can put it anywhere. I'm just put it right there. And then here's where the segment comes in. You watching? So the segment comes in where I take the end of this radius and I connect it with the end of the other radius. There's your segment right there, that red one. So I put it in a different color. That's your segment. Okay, but what's the segment of the circle? The segment of the circle is this part right here. We're not shading in the whole sector. All right, do you remember on this one? We shaded in that whole entire thing. Watch what we're shading in this time. We're only shading in from that line segment to the edge of the circle. Okay, so this part right here is what we're going to try to find the area of. Okay, that right there is the what? The segment of the circle. So it's kind of similar to what we did. It's a piece of the pie, right? Would you agree? We talked about this whole entire sector being the piece of the pie, right? This is a part or a piece of that piece of the pie. So it's not the whole entire piece of the pie. It's a smaller portion. So let's think about this for a second. What if, let's put some colors in here. What if I shaded in this? What kind of figure am I shading in right now in yellow? What kind of shape? It's a triangle, exactly. You see that? So everything shaded in right there. That yellow one is a triangle. What's the sector? The sector is the combination of the two. You see that? Some of you guys, are you really trying to stay awake? Like Josh, are you giving it a valiant effort? I don't think so. Okay, come on. Be strong. Be strong mentally. Mentally strong. Should I say this or not? Yeah, why not? You know Shedeur Sanders, right? Yeah, he went the 5th round. He thought he was going in the 1st round. You know what I think? And I've read some articles on this. You know what I think a big reason is? I don't think it was physically, okay? I think it was because he's not mentally strong. I've read a lot of reports on that. He had interviews. He wouldn't do a lot of things. He wouldn't answer a lot of questions because I don't think he's mentally strong. You can have all the physical attributes in the world, but I think that's a part of the reason. It's not the whole reason, but I think that's part of it. Part of it, I just don't think he's mentally strong. So you guys might have physical attributes, but you know what I think is super important? I think is the mental state of mind. All right? You guys watch the guys like, oh my gosh, I can't believe I forgot his name. Who's the Eagles quarterback? Jalen Hurts. He's physically, he's okay. Strong guy. Super, super strong. Okay? He's probably not as fast as a lot of quarterbacks. Probably doesn't have as good an arm as a lot of quarterbacks. He's not super tall. Right? He doesn't have, like, physical characteristics that stand out. But you know what he's got? And I've read and heard a lot of people talk about that. He's a brilliant guy. He's really, really smart. Right? I mean, that's why he's such a good quarterback. All right? Because of his mental ability. He stays strong. You watch him. He doesn't get overly emotional, right? I wish he'd get a little bit more emotional, to tell you the truth. Okay? Yeah, at least a smile would be nice. I think he did smile after they won the Super Bowl. But the thing about Jalen is his mental capabilities. He's a really smart guy, really cerebral. He's not super emotional at all right? And I think that's what makes him such a good quarterback. There's a lot of quarterbacks that physically are probably better than he is. But I think he's got what it takes. That's what I'm trying to stress to you guys, okay? Especially since the majority of you guys are athletes and you understand that kind of stuff. Let's be mentally strong in the classroom. It takes as much mental fortitude as it does physical, all right? You got to know that. If you're going to go to the next level, okay, if you're going to go to the next level, you got to train your brain to be able to sit and stay awake. You go to college, you're going to be sitting in meetings all the time. They're going to be talking about all these things, and sometimes it's going to get boring. And if your first instinct is to fall asleep, you're not going to be on the team any longer. All right? I'm telling you. You've got to be able to stay awake. Even for stuff, and you're like, well, it's football. I'm going to be really interested in it. Not all the time. All right, you ever sat through film and it's just so boring and you're just trying to, right, just bang yourself in the head to stay awake? All right, let's do it here. All right, you do that when you're watching film, do that in here. All right, enough said about that. Let's keep going. What about this whole entire thing? Watch, let me just, I'm not going to shade it in because it'll make it too much of a mess. But look at the blue. What is that? We just learned what that word was. That's a sector. Everything in blue. I'm not going to shade it in because it'll cover up all the other stuff, okay? But that blue one is the sector. How do I find the segment of the circle? How do I find the red? Okay, so let's write this down. I'm going to write it down right here. How do I find the segment? Watch, if I can find the whole sector, and you should know how to find the sector, we just talked about it. If I can find the whole sector, and I can find that triangle, what am I going to do to that sector, the whole blue and the yellow, to find the red? What am I going to do to those? What math thing am I going to do to those? By how? Divide? Look. The whole sector is everything, right? Would you agree? This blue is everything. I want to find this little part right here. So if I have the yellow, what am I going to do with the yellow to the blue to find out what's left over? Subtract. Very good. See how nice it is to stay awake? And now you can answer questions. Don't you feel better now? All right, so if I take the whole sector and subtract the what? The triangle from it, guess what's going to be left over? The segment. Everybody see it? If I take the blue minus the yellow, I'm sorry, yeah, that's right. If I take the blue minus the yellow, what am I going to be left with? The red, the segment. You got it? Okay, that's what we're doing here. So that's super important right there. That in order to find that segment, you take the blue minus the yellow, and that's going to give you the segment. We good? All right. So now let's do a real example. Everybody ready for that? Good. Now this is the one where I was warning you at the very beginning. This one is quite a few steps. But if you followed what we've been doing up to this point, and you remember a couple things that we've talked about in the past, you should be able to do this. Everybody should be able to do this. But it's not super easy. You don't just do one thing. You don't just look at it and come up with an answer. You don't just put one thing into a calculator and come up with an answer. It takes several steps. So follow me on all these steps. All right, there's your central angle. There's your sector. Everybody got that? I'm going to draw from here to here, which creates a what? Okay, a triangle and a what? And a segment. That's right. Okay, this little part right there, I'm not going to shade it in, but that part right there, I'll tell you what, I will shade it in. We made it red before, right? Okay, let's make it red again. So this is what I'm trying to find. Okay? Now, they tell you a couple things. They tell you this whole angle, this central angle right here is 84 degrees. And they tell you the whole bottom of this triangle right here is 4, whatever it is, centimeters, doesn't matter. I'm just going to put a 4 there. And they tell you the radius of it is 3. So this is everything they give you. And you have to find the area of just the red stuff. So what was our little formula? Do you remember how to find the segment? You should have just written it down just before this. The area of the segment is equal to the area of the sector, what? Minus the area of the triangle. I didn't write the word area in here, but that's what all these mean, okay? Area of the sector, area of the segment, area of the sector, area of the triangle. So let's find the sector first. That should be pretty easy, okay? So I'm going to write it down. So let's find the sector first. How do I find the area? I'll put A, area of the sector. Remember that? Take the central angle, 84 divided by what? 360 times pi times r squared. Tell you what, let's put the actual number in for pi. Is that all right? times 3.14 times the radius squared. What is the radius? 3, and we square it. All right, I'll save you the time. Let me flip my paper over so I remember what my numbers are. 6.6 it comes out to be. And it's approximately 6.6. We'll call it centimeters, so it's centimeters squared. I'm going to put that in a box. It's not my answer. I'm just going to put it in a box just for safekeeping. I'll come back to it. Okay? So I found the area of the sector. Now what do I have to find? Area of the what? Triangle. This is the hard part. Well, I wouldn't say it's hard, but it's harder. It's harder. Let's look at this. I'll give you a little hint. You're going to take a perpendicular line, drop it right down to the bottom of that triangle. That way, I have a right triangle. And I know how to do some stuff with that right triangle. Would you agree? I'm going to draw that triangle over here by itself, just to kind of get it away from all the stuff. It's a little bit easier to see this way. All right, do you see that blue triangle right there, that right triangle? So what's this side right here? What's the hypotenuse of that triangle? It's 3. Okay. What's the bottom of this? Is it 4? That's right. It's half of this thing. This 4 goes from here all the way to there. So this is what? 2. Why did I put this straight line up and down here? Because that's my height of the triangle, isn't it? Remember that? That's the height of the triangle. So now, how can I find the height of that triangle? What am I going to use? I'm going to use a theorem. I only got 5 minutes left, so I got to hurry. Pythagorean theorem, very good. Okay, so let's do it. Let's use Pythagorean theorem. So how do I do it? I take the 2 legs, I square them, I add them up. So that's h squared. Stop dropping the ball, whoever's doing that. Plus what? 2 squared equals 3 squared. Go back and learn that, okay? If you didn't learn it, that's why we learned it, so we could do it later. So let's figure out what this is. This is h squared plus 2 squared is 4 equals 3 squared is 9. Okay? Subtract 4 from both sides. So h squared equals 5. How do I get h by itself, though? It's h squared is 5. How do I get rid of that squared? Square root both sides. So if I square root both sides, I get the square root of 5. Okay, that's basic Pythagorean theorem. Okay, we've done that before. We learned it probably in this chapter. I think we learned it in this chapter. I think. Doesn't matter. We learned it some other time. So that's what h is. H is the square root of 5. Why did I care what h was? I got to find the area of the triangle. That's right. I'll tell you what. Let's do this. Let's get rid of this now. So I got to find the area of a triangle. How do I find the area of a triangle? Base times what? Height divided by 2. Do I know the base of this triangle right here? It's the whole entire base, which is what? Is it 2 or is it 4? It's 4. It's the whole triangle. It's 4. So the base is 4 times the height. What is the height? Just found it. It's not 5. It's a square root of 5. Over what? 2. So that goes once, that goes twice, so it's 2 square root of 5. If you wanted to put that into a calculator, it rounds to about 4.5. I'll put that in a box. I'll put it in a calculator. Okay, from here to here. Oh, why did I put a 4 here? Because it's the base of that whole entire triangle. Remember, I'm trying to find the area of this whole triangle, not just half the triangle. All right, so the base of the whole triangle is 4. All right, so that's why I put a 4 there. And then I just stuck that into a calculator, 2 times the square root of 5, and I got approximately 4.5. We're basically done now, okay? One little tiny step. Do you remember what our step was? To take the sector minus the triangle. What was the sector? So the area of the segment is equal to, say it, 6.6 minus what? 4.5, and you get what? 2.1. This is in centimeters, so this is centimeters what? Squared. So the area of the segment is 2.1 centimeters squared. So it took a few steps, didn't it? All right, especially to find the area of the triangle. Okay, area of the sector is pretty easy. You just take that angle, divide it by 360, pi r squared, chuck all that into your calculator, you get around 6.6 when you round it. Finding the triangle was a little bit tougher, but you had to know to drop this perpendicular. Okay, they didn't tell you to do that, but I'm telling you. All right, so you drop the perpendicular, you got a right triangle out of it. This whole base is 4, so the half of this is 2. That's a 3. Pythagorean theorem, you get square root of 5, which is the height. Why did you need the height? Because you got to find the area of the triangle. So the area of the triangle is the base times the height, 4 times the square root of 5 over 2. Throw that into a calculator, you get 4.5 approximately. And now, that was the hardest part right there, was to find the area of that triangle. Once you do that, you just take the sector minus the triangle, and you get 2.1, and you're done. So now, you just found the area of the stuff that's shaded in red. And there you go. You probably, I haven't looked at the homework, but you probably won't have to do one of those tonight. But tomorrow I'm going to give you a part B, and that's probably where that problem will show up. Okay? But here's what you should do. I told my last class this. What you should do, all right, this is your responsibility. Nate, didn't I ask you? So what you should do is do this problem before you do any homework tonight. You should take that example, write it out. You should try it yourself. If you get stuck, go back to your notes. Go back to watch the video, all right, if you get stuck. Keep doing it until you can do that problem completely on your own. Nobody's listening to me. Pay attention to me. I'm giving you a huge hint here. You should do this problem, this example. You should do it until you can do it completely by yourself without checking notes, without checking the video. Okay? I wouldn't even start the homework until you could do that here. That's what your responsibility is. Okay? That's how you're going to learn how to do these problems. But most of you won't. Most of you are going to go home, not even think about it. 10 minutes before class, you're in your other class, I better write something down for the homework. I know that's how it normally goes. Not for everybody, but some people. All right? So take my word and do it the way that I told you to do it. Let me write this down first. So this was not on the lesson plans A and B, but I talked about that earlier. So you're doing 1 through 10, and you're doing 13 to 18. That's your homework. That's going to be due tomorrow. All right, so have that done.